In this video, we're going to continue from where we left off at in the previous video with talking about imaginary numbers. But previously we talked about the fact that I is an imaginary number and it represents the value of the square root of -1. In this video, the key element is to know that I squared is -1. That's very important. Anytime we have an I squared, that value is -1. Now let's look at some situations where we'll need to know that. For example, in this very first one, I have 5i times 3i. Well, 5 times 3 is 15. That's easy enough. And I times I is I squared. So we treat I essentially as like any other variable, with this one exception, that I squared, whenever we have an I squared, its value is -1. So 15 times I squared is the same as 15 times -1, which is -15. Let's look at the next one. Anytime we have the square root of a negative number, I can do nothing with it until I make it positive. So the square root of -16, I make it positive by taking out an I. So this is I square root of 16 minus I square root of 64. The next thing I do is if I have the square root of a number, I see if I can simplify it. Well, the square root of 16 is 4, so this would be 4i. And the square root of 64, that also simplifies to be 8, so it would be 8i. And now I can, again, we treat this just like I would a variable. If I had 4x minus 8x, I could simplify that. So if I have 4i minus 8i, I can simplify it, and I would get -4i as my answer. Let's look at the next one. The next one, I have the square root of -2. Again, I can't do anything with that until I make it positive, so I take out an I, so now I have I square root of 2 plus I square root of 2. Now this is where it gets a little tricky. I can't simplify the square root of 2. But since these are the same numbers underneath the radical, the square root of 2 and a square root of 2, I can add these two terms together. I square root of 2 plus another I square root of 2 is going to be 2 i's times the square root of 2. It's not the square root of 4, it's the square root of 2. So essentially what we're doing is the fact that these are the same roots, we're just adding the two pieces outside the radical. So it would be the square root of 2 plus, or I square root of 2 plus I square root of 2. We add the two parts outside the radical. Well, I plus I is 2i, and what's under the radical stays the same. So it would be 2i times the square root of 2 would be your final answer. Okay, let's look at the last one. Again, I can simplify this by taking out an I, so it would be I square root of 100 over I square root of 81. And 100, the square root of 100 is 10, so this would be 10i over, and the square root of 81 is 9, so this would be over 9i. This is not completely simplified because I can cancel out the i's here, so this reduces to be 10/9. Okay, why don't you guys try these next examples on your own. So why don't you pause the video and hit play when you're ready to check your answer. Okay, so let's see what you got. So for this first one, you should have gotten 70 as your answer, but here's how you'd get it. You'd first multiply the 7 and -10 together. That gives you -70. I times I is I squared. Again, I squared is the same as -1, so -70 times -1 is a +70. Let's look at the next one. We take out an I, so it's going to be -I square root of 25 minus I square root of 100. By the way, this negative and the negative inside the radical, we don't multiply those together to make it a +25. The only way to make this a +25 is to take the I out. So it's okay to have a negative I out in front of there. Okay, now square root of 25 is 5, so I'm going to write this as -5i minus, and the square root of 100 is 10, so this will be -10i. Remember the proper way to write these from the previous video is that we always put the number in front of the I just like an x. You wouldn't write x times 5, we'd write it as -5x. So we do the same thing with the I. So we -5i minus 10i. And this can be simplified further to be -15i. Change the color here to be consistent. Okay, let's go to the next one. Again, can't do anything with the square root until we make it positive underneath the radicals. So I'm going to take out an I, so it would be I square root of 3 plus I square root of 3. add those together, I plus I is 2I, so I'd have 2I, and then, like I said, these stay the same, so it's going to be 2I times the square root of 3. The last one, again, take out an I to make these positive under the radical, so it's going to be I squared root of 25 over I squared root of 64. Well, the i's are going to cancel out in the long run, so we can cancel those out now if you'd like. And the square root of 25 is 5, the square root of 64 is 8, so we get 5/8 as your answer. Now, in your assignment, there's going to be one other example that we didn't talk about here, so let's look at what that example is going to be. And it's going to be one like this. Number 17 in your assignment is square root of -5 times the square root of -10. Now, it's similar to what we did here in example A for these two pieces, but we have them written as square roots. So the first step is to take out an I to make these positive. So if I do that, it's going to be I square root of 5 times I square root of 10. Now I can't take the square root of 5, I can't take the square root of 10, so I'm going to have to multiply these together. Now, previously, when we were adding square roots, or subtracting square roots, we always wanted to look to see if they could be simplified. Now, in order to add them, the only way to combine these, going back to this example here in example C, the only way to add these together is if what's under the radical is the same value. So having the square root of 3 and the square root of 3 here, being able to add those, or being the fact that they have the same number under the radical, I can add those together. If this had been the square root of 3, or I square root of 3 plus I square root of 2, I would not be able to simplify it because there's different numbers under the radical, so I would leave it like this. But multiplying does not follow the same rules. When we multiply, we can just go ahead and multiply by whatever is under the radical. So for this one, outside the radical, I'd have I times I, which is I squared. And square root of 5 times square root of 10 would be square root of 50. Now the square root of 50, I want to see, there's no integer times itself that would give me 50, so I'm going to see if I can simplify this further by using a factor tree. So 50 is the same as 5 times 10. 10 is the same as 5 times 2. So for every 2 the same number, since it's a square root, I can take 1 out, so I can factor out a 5 here. And I squared, remember, is -1, so this would be -1 times 5 times the square root of 2, because that's what square root of 50 simplifies to be 5 square root of 2. But don't forget, we have the I squared, which is -1, so my answer would be -5 times the square root of 2. So, relatively quick and easy lesson here, but again, the key to this portion of the video is to remember that I squared is the same as -1, and remember from yesterday, or the previous video, that if we have the square root of a negative number, we have to take out the negative, or take out an I, and make what's under the radical positive before we can do anything else. So, with that, good luck on your assignment.